This call is now being recorded.
Okay. So once again, good morning. So in the last lecture, we have started with the graphical method or the Mohr circle method of the chapter number 3. And based on this, the two problems we have solved based on the case number 2, where the body or the member is subjected to the biaxial stresses. That means it is subjected to the sigma x and the sigma y. So in the previous lecture, we have solved the two problems where both the stresses are tensile, that is sigma x and the sigma y both are tensile. And whatever the second problem we have solved, in that one stress is tensile and another stress is compressive. So due to that particular compressive, so one location or the whatever that point B is located, it is located at the left side of the origin. Okay, so related to that, yesterday we have discussed that particular two problems, their detailed procedures. So now today in the today's lecture we will solve one problem based on the case number 3. So what is that particular case number 3, where your member or body subjected to the biaxial stresses, along with it is subjected to one shear stress. So we'll just read the statement. The figure is also given, and then we will follow the procedure how to draw the Mohr circle. So procedure to draw the Mohr circle for the case number 2 and the case number 3, it is somewhat different. Okay, so through this particular problem, we will just check where we have to change the procedure and how to draw the Mohr circle. Okay, so please be ready with your all the drawing instruments to draw this particular Mohr circle and to find out the unknown parameters. So at a point in a strained material subjected to the stresses shown in the figure. So whatever the stress distribution is there on that particular body, so their figure is also given. Determine tangential and the resultant stresses across the oblique plane by the Mohr circle method. That means we have to solve this particular problem by using the Mohr circle, means it is graphical method. We have to calculate tangential and the resultant stress, that means sigma t and sigma r we have to calculate. Also determine angle of obliquity and check answers analytically. That means angle of obliquity means that phi also we have to calculate, and whatever the answers you will get through this particular graphical method, you have to check that all the answers through the analytical method. So for the case number 3, we are having the list of the formulas. Through this particular formulas also we can verify all the answers. So okay, so now whatever the figure is given, through this particular figure also we can easily identify that this particular statement or this problem is based on the case number 3. Why? Because it is subjected to the 3 stresses. So you can see here the sigma x is 100 Newton per mm square, which is applied on the vertical plane or the major principal plane. Then sigma y, it is 40 Newton per mm square, which is also applied on the minor principal plane or the horizontal plane. Both are tensile. Sigma x, sigma y, according to their direction, both are tensile. And one more stress is applied, which is called as a shear stress. So here you can see 20 Newton per mm square. This is the shear stress is applied, which is parallel to the all the types of planes. That means this is the problem based on the case number 3. Okay. So before solving this particular problem, just we will write all the given parameters. So let us see here. Sigma x is equal to 100 Newton per mm square, which is tensile. Sigma y is equal to 40 Newton per mm square. Again, it is tensile. In the figure, the shear stress is also given. Tau is equal to 20 Newton per mm square. Now, please tell me, according to the set of the shear stress, whether that shear stress we have to take positive or negative. Apply the sign conventions. We are having the figure A and figure B.
Positive. Positive.
The shear stress is positive because this particular set is given, their sign conventions I have given. Also, we are having one statement. If the shear stress is rotated in anti-clockwise direction with major principal plane. So, one shear stress, it is rotated in anti-clockwise direction with major principal plane. So, for that purpose, we have to take this particular shear stress as a positive by the sign conventions. Okay. Then theta is also given 45 degree. Already the theta is given with the major principal plane or the vertical plane, so need not require to change it. So we have to take this particular theta as it is for your further calculation. If theta is equal to 45 degree, so I can take 2 theta is equal to 90 degree. And we have to calculate normal stress. We have to not calculate, but then also we will calculate. Then sigma t tangential stress, sigma r resultant stress, and phi angle of obliquity we have to calculate. So these are our unknown parameters. Now, first of all, we have to draw the Mohr circle for this particular case number 3. And one small change is there. While drawing this particular Mohr circle, whatever the procedure we have followed for the case number 2 or previous 2 numericals, same procedure we have to follow, but one small difference is there for the case number 3 that we will discuss now. Okay, now it has been observed that both the stresses are positive, that is sigma x and sigma y. So whatever maximum figure you will get, it will be generated at the right side of the origin. So accordingly, I will draw the vertical axis and the horizontal axis. Okay, so this is the vertical axis and the horizontal axis. So this is plus sigma here, minus sigma. This is origin point O. This is plus tau, and at the bottom side this is minus 2. So accordingly, you also draw this particular vertical axis in your notebook. Make your notebook horizontal. Here again we have to select the scale. 1 centimeter is equal to 10 Newton per mm square. This is the scale we have selected to draw the Mohr circle. So draw the vertical axis and the horizontal axis in your notebook. Give the maximum space at the right side of the origin, because total figure you will get at the right side only, because the stress sigma x and sigma y both are positive. Okay, so according to this particular scale, whatever we have selected, so accordingly you have to write down sigma x is equal to 100 Newton per mm square. So if I will apply the scale here, so 100 Newton per mm square means it becomes 10 centimeter. Similarly, sigma y is equal to 40 Newton per mm square. That means it becomes 4 centimeter. The shear stress is also given. In the previous 2 numericals, we have not used our vertical axis. In your previous 2 numericals, we have not used our vertical axis. Only horizontal axis we have used for the sigma x and sigma y location. But here the shear stress is also given. So here now we have to use our vertical axis also. Therefore, if the tau is given 20 Newton per mm square, then it is equal to 2 centimeter. So how it is selected? By this scale. So 10 centimeter, 4 centimeter, and the 2 centimeter. So write down this particular all the parameters in your notebook also, and accordingly convert it according to the selected scale. Okay. So now we have to draw the Mohr circle. So what we have to do? Let us see. Same procedure we have to follow. That is, sigma x is equal to 100 Newton per mm square and sigma y is equal to 40 Newton per mm square. Both are tensile. So both will be located at the right side of the origin. So first, from this origin point O, locate the point A. From this origin point O, locate the point A as a 10 centimeter, because point A represents the position of sigma x. So at the bottom side, I will write down the meaning of the point A, that is sigma x is equal to 100 Newton per mm square is equal to 10 centimeter. So this is the location of point A. Similarly, locate the location of point B. So it represents 4 centimeter distance from the origin point O. That means we have to represent the location of point B, that is sigma y value. It is having 40 Newton per mm square, that is 4 centimeter. So from this origin point O, take 4 centimeter distance at the right side and locate the point B. So this is sigma y is equal to 40 Newton per mm square is equal to 4 centimeter. Okay. So this is the location of point A and the location of point B. So the distance between point A and B. What is the distance between point A and B? It is, I think, 6 centimeter. So don't locate the point C here. In the previous two numericals, what we have done? We have taken the center point of AB as a point C. Maybe now here also you will get the 3 centimeter from the B side and the 3 centimeter from the A side. But here don't locate, because here we have to follow some another procedure for the case number 3. Now the point A is located, point B is located. Now we have to locate the shear stress point, that is whatever the shear stress is given, tau 20 Newton per mm square, and it is converted into the 2 centimeter. So that shear stress also we have to locate. But here we have to apply some sign conventions. So what we have to do, let us see. I will tell the sign conventions. If the shear stress is rotate in anticlockwise direction with major principal plane. See, if the shear stress is rotate in anticlockwise direction with major principal plane, represent that shear stress in negative region. If the shear stress is rotate in anticlockwise direction with major principal plane or vertical plane, then that shear stress we have to represent in the negative region. And if the shear stress is rotate in clockwise direction with minor principal plane or horizontal plane, then that shear stress we have to represent in the positive region. Now here please tell me, from this particular stress distribution diagram, with major principal plane, shear stress is rotate in anti-clockwise or clockwise direction?
Anti-clockwise.
Anti-clockwise. And with minor principal plane, it is rotating anti-clockwise or clockwise direction?
Clockwise.
Clockwise direction. You can see here horizontal plane. त्या horizontal plane ला हा 20 न्यूटन पर mm स्क्वेअर कसा रोटेट होतोय तर क्लॉकवाइज डायरेक्शन मध्ये रोटेट होतोय. आणि ह्या मेजर प्रिन्सिपल प्लेनला म्हणजेच व्हर्टिकल प्लेनला हा कसा रोटेट होतोय तर अँटी क्लॉकवाइज डायरेक्शन मध्ये रोटेट होतोय. म्हणजे मेजर प्रिन्सिपल प्लेनवर तुमचा 100 न्यूटन पर mm स्क्वेअर स्ट्रेस काय झालेला आहे, ऍक्ट झालेला आहे. म्हणजेच आपण हा कुठल्या पॉइंटने इंडिकेट केलाय, पॉइंट ए ने इंडिकेट केलेला आहे. सिमिलरली ह्या मायनर प्रिन्सिपल प्लेनवर तुमचा 40 न्यूटन पर mm स्क्वेअर हा टेन्साइल स्ट्रेस ऍक्ट झालेला आहे. तर हा 40 न्यूटन पर mm स्क्वेअर आपण कुठल्या पॉइंटने इंडिकेट केलाय तर पॉइंट बी ने इंडिकेट केलेला आहे. मग आता ह्या पॉइंट ए वर आणि ह्या पॉइंट बी वर आपल्याला शियर स्ट्रेस पण काय करायचा आहे, त्या मोर सर्कलवर काय करायचं आहे, इंडिकेट करायचं आहे. तर पॉइंट ए म्हणजे तुमचा कुठला सांगतोय, सिग्मा एक्स 100 न्यूटन पर mm स्क्वेअर सांगतोय. अँड पॉइंट बी म्हणजे तुमचा काय सांगतोय, सिग्मा वाय दॅट इज 40 न्यूटन पर mm square. Therefore, in this particular figure, the 100 Newton per mm square stress is applied on the major principal plane. बघा 100 न्यूटन पर mm स्क्वेअर हा स्ट्रेस मेजर प्रिन्सिपल प्लेन म्हणजेच व्हर्टिकल प्लेनवर ऍक्ट झालेला आहे. आणि त्या व्हर्टिकल प्लेनला हा शियर स्ट्रेस अँटी क्लॉकवाइज डायरेक्शन मध्ये रोटेट होतोय. मग तो काय करायचा आहे आपल्याला तर निगेटिव्ह रिजन मध्ये काय करायचा आहे, इंडिकेट करायचा आहे. नाउ प्लीज टेल मी, above the x-axis this is the positive region and below the x-axis this is the negative region. Then tell me, according to the given sign convention, major principal plane ला जो काय तुमचा शियर स्ट्रेस रोटेट होतोय तो अँटी क्लॉकवाइज डायरेक्शन मध्ये रोटेट होतोय. मग तो शियर स्ट्रेस मला एक्स ऍक्सिसच्या वरच्या बाजूला लोकेट करायचा आहे का खालच्या बाजूला लोकेट करायचा आहे?
Bottom side.
At the bottom side, because it is negative. So what do you do? Let us see. From this particular point A, why point A? Because this point A represents the position of 100 Newton per mm square. आणि तो 100 न्यूटन पर mm square चा स्ट्रेस कुठल्या प्लेनवर ऍक्ट झालेला आहे, मेजर प्रिन्सिपल प्लेन. म्हणजे हा पॉइंट ए तुमचा काय सांगतोय, लोकेशन ऑफ सिग्मा एक्स एज वेल एज लोकेशन ऑफ मेजर प्रिन्सिपल प्लेन. पॉइंट ए काय सांगतोय तो तुमचा लोकेशन ऑफ सिग्मा एक्स आणि लोकेशन ऑफ मेजर प्रिन्सिपल प्लेन. मग ह्या मेजर प्रिन्सिपल प्लेनला एक शियर स्ट्रेस हा अँटी क्लॉकवाईज डायरेक्शन मध्ये रोटेट होतोय, त्यामुळं तो काय करायचा आहे, निगेटिव्ह रिजन मध्ये घ्यायचा. त्यामुळे काय करा बघा, फ्रॉम दिस पर्टिक्युलर पॉइंट ए रिप्रेझेंट 2 सेंटीमीटर डिस्टन्स, represent 2 centimeter distance in the bottom side. So tau is equal to 20 Newton per mm square is equal to 2 centimeter. So take 2 centimeter distance at the bottom side from the point A. Similarly, from this particular point B, this point B represents the position or location of sigma y, as well as it represents the location or position of minor principal plane. मग ह्या मायनर प्रिन्सिपल प्लेनला तुमचा शियर स्ट्रेस हा क्लॉकवाईज डायरेक्शन मध्ये रोटेट होतोय, आणि जर तो क्लॉकवाईज मध्ये होत असेल तर तो शियर स्ट्रेस आपल्याला कसा इंडिकेट करायचा आहे, तर पॉझिटिव्ह मध्ये इंडिकेट करायचा आहे. मग तो एक्स ऍक्सिसच्या वरच्या बाजूला येणार आहे का खालच्या बाजूला येणार आहे? येस, मायनर प्रिन्सिपल प्लेनला जर शियर स्ट्रेस क्लॉकवाईज डायरेक्शन मध्ये रोटेट होत असेल तो इट शुड बी रिप्रेझेंटेड इन द पॉझिटिव्ह रिजन, but then it is top side of the x-axis or bottom side of the x-axis?
Top side.
Top side. Okay. So this point B represents the location of sigma y as well as location of minor principal plane. मग त्याच्यावर पण तुमचा किती न्यूटन पर एम एम स्क्वेअरचा शियर स्ट्रेस आहे? 20 न्यूटन पर एम एम स्क्वेअर. मग ह्या पॉइंट बी पासून वरच्या बाजूला 2 सेंटीमीटर वर शियर स्ट्रेस रिप्रेझेंट करा. सो दिस इज टाउ इज इक्वल टू 20 न्यूटन पर एम एम स्क्वेअर इज इक्वल टू 2 सेंटीमीटर. मग पॉइंट ए पासून आपण जो ड्रॉ केला त्याला जी पॉइंट म्हणा, आणि पॉइंट बी पासून जो वरच्या बाजूला इंडिकेट केला त्याला एच पॉइंट म्हणा. whatever the one shear stress we have located at point A at 2 centimeter, represent that point G, and from point B I have represented shear stress in the positive region at 2 centimeter, represent that particular point as a H, and then join point H and G, you will get inclined line. Let us see. Join the point G and H, you will get inclined line, and in between AB you will get one new point, that is point C. In between AB you will get new point, that is point C. Understand the difference between previous case and this case. For the case number 2, directly I have taken the center point as a C, but here first of all at point A I have represented the shear stress 2 centimeter, at point B I have represented shear stress to 2 centimeter, and then I have drawn inclined line, and due to this inclined line I got this particular point C. Okay, once the point C is located, take the radius CH or CG. Don't take the radius CB or CA. That CB or CA radius we have taken for the previous 2 numericals or for case number 2. But here don't take CB or CA radius. Take the inclined radius CH or CG and draw one circle which is passes through the point H and G. The circle will not pass through the point B and A. Why? Because I have not taken the radius CB or CA. So take the radius CH or CG. Take the radius CH or CG, or draw one circle which is passes through the point C and G. So let us see. The circle should be passes through the point H and G. The circle should be passes through the point H and G. It should not be passes through the point B and A, because we have not taken radius CB or CA. We have taken radius CH or CG. Okay. So due to that particular circle, again you will get the 2 new points on the horizontal axis. बघा ए च्या शेजारी जिथून सर्कल पास झालंय त्या ए च्या शेजारी तुम्हाला एक पॉईंट मिळतोय, त्या पॉइंटला म्हणा कॅपिटल पी. तसंच ह्या बी च्या शेजारी ड्यू टू द सर्कल इज पासेस थ्रू द हॉरिझॉन्टल ऍक्सिस you will get new point which is called as a point Q. So you will get the two new points, that is point P and point Q on the horizontal axis due to the circle is passes through it. So take the radius CH or CG, draw one circle which is passes through the H point and the G point. Due to this circle you will get the two new points, that is point P and Q on the horizontal axis. Okay, so understand the difference between केस नंबर 2 अँड केस नंबर 3. केस नंबर 2 मध्ये आपण काय करतो, तो ए बी चा सेंटर घेतो तो पॉइंट सी आणि तो पॉइंट सी मधून सीबी किंवा सीए एवढी रेडियस घेऊन आपण सर्कल ड्रॉ करत होतो. पण इथं आपण काय केले, पॉइंट ए पासून जी आणि पॉइंट बी पासून एच पॉइंट लोकेट केले, ते दोन पॉइंट जॉईन केले, तुम्हाला एक इन्क्लाइन लाईन मिळाली. त्या इन्क्लाइन लाईन मुळे तुम्हाला हा सी पॉइंट मिळाला आणि त्या सी पॉइंट मधून एच मधून आणि जी मधून जाणार मी सर्कल ड्रॉ केलं आणि त्यामुळे मला अजून दोन न्यू पॉइंट मिळाले, ते म्हणजे कुठले, पी अँड क्यू. नाव थिटा इज गिवन 45 डिग्री, सो 2 theta is equal to 90 degree. So actually why we have to take this particular 2 theta, because there is one parametric equation is there, so that derivation is not in your syllabus. So one parametric equation is there, through this particular parametric equation you have to represent this particular 2 theta angle. Why we have not taken the theta? Because in the analytical method also, ज्यावेळेस आपण केस नंबर 2 आणि केस नंबर 3 चे फॉर्म्युले आपण सॉल्व्ह केले, त्याच्यामध्ये सिग्मा एन आणि सिग्मा टी ह्या फॉर्म्युल्यामध्ये ज्या काय कॉस आणि साइनच्या टर्म आहेत, त्या कॉस आणि साइनच्या टर्म आपण कशामध्ये आहेत, 2 थिटाच्या फॉर्म मध्ये आहेत. कॉस 2 थिटा, साइन 2 थिटा. जर आपल्याला अनालिटिकल आणि ग्राफिकल मेथडचे जर आन्सर जर आपल्याला मॅच करायचे असतील, तर इन केस ऑफ ए अनालिटिकल ऑल्सो आय हॅव टेकन द 2 थिटा. So similarly in case of a graphical also I have to take the 2 theta angle. जर एकीकडे थिटा घेतला आणि दुसरीकडे 2 theta घेतला, तर your answers of graphical and analytical method will not be matched. Therefore in the graphical method also I have taken the 2 theta angle. Okay, so now 2 theta is equal to 90 degree. So now here take the reference line as a CG. पहिल्या दोन न्यूमरिकलला आपण सीए ही रेफरन्स लाईन घेतली होती आणि त्या सीए पासून अँटी क्लॉकवाईज डायरेक्शन पासून आपण 2 थिटा अँगल काय केला होता, रिप्रेझेंट केला होता. बट हियर इन्स्टेड ऑफ टेकिंग द लाईन सीए, टेक द इन्क्लाइन्ड लाईन सीजी ऍज अ रेफरन्स लाईन आणि ह्या पॉइंट सी पासून आणि ह्या पॉइंट जी पासून अँटी क्लॉकवाईज डायरेक्शन मध्ये आपल्याला 2 थिटा अँगल काय करायचा आहे, रिप्रेझेंट करायचा आहे. सो फॉर एक्झाम्पल इफ आय विल रिप्रेझेंट this, so 2 theta is equal to 90 degree from which line, CG line, and here you will get the new point as a point D. So this is 2 theta. Take the reference line CG, don't take the reference line CA. That reference line CA we have taken for the case number 2, and for case number 3 you have to take this inclined line as a reference line, and from that particular inclined line or from this particular point G represents the 2 theta angle in anti-clockwise direction. So you will get the 90 degree. So you will get the 90 degree. And due to this particular 2 theta angle, you will get one new point on the circle which is called as a point D, like previous case. Due to this particular 2 theta angle, you will get one new point D on the circle. Now the remaining procedure is same. From this particular D point, draw one vertical line in the downward direction. From this particular point D, draw one vertical line in downward direction. So at the downward point on the horizontal axis, you will get new point as a capital E, like previous case. From this particular point D, draw the vertical line in the downward direction. You will get one new point on the horizontal. So that point should be in between C and A. Whatever the E point you will get, it will be in point A and C. Similarly, draw the inclined line or join OD distance. So from this particular origin point up to the point D, draw this particular line by the dotted lines. Okay, so this is OD distance. So angle DOE, this is called as a angle phi. Angle DOE, this is called as a angle phi. Then your sigma R, you know, sigma R is equal to OD distance. So this is your sigma R. Okay. Then DE distance from this particular D point, I have drawn vertical line. You will get new point. So this DE distance is equal to sigma T. And OE distance from this particular point O up to the point E. This OE distance, it will be represented as a sigma N. It will be represented as a sigma N. So this is the procedure. Draw the Mohr circle for the case number 3. But काय difference आहे? In case number 2, I have taken the center point C directly in between A and B. But here, due to taken that center A पासून मी G आणि H point represent केले, म्हणजेच काय केला? I have located the shear stress at 2 centimeter. त्याच्यासाठी sign conventions आहेत. So that sign conventions I have represented through this particular figure. Major principal plane ला जर shear stress anti-clockwise direction मध्ये rotate होत असेल, it will be represented in the negative region. जर major principal plane ला clockwise मध्ये rotate होत असेल, तर तो positive मध्ये जाणार, म्हणजे vice versa. आणि minor principal plane ला initially जर तो clockwise मध्ये होत असेल, तर तो positive झाला, आणि minor principal plane ला anti-clockwise मध्ये जात असेल, तर तो काय झाला? Negative region मध्ये झाला. But according to the our loading diagram, I have given the sign conventions. मग inclined line I have drawn due to that particular inclined line. I got the point C, and by taking the radius CH or CG, I have drawn one circle, and that circle is passes through the point H and G only. Then you will get new points P and Q. Then by taking the reference line CG, or from this particular point G, I have represented the 2 theta angle, that is 90 degree. You will get the new point D, and D पासून एक inclined line केली, it will get point E. Then I have joined the OD distance by the dotted lines, and now I have to represent the our unknown parameters. So let us see from figure. First, sigma N is equal to OE into scale. Sigma T is equal to DE into scale. Sigma R is equal to OD into scale. And fourth, phi is equal to angle DOE is equal to. Now tell me the distances. What is the first distance? OE distance. What is your OE distance? 9.1. Yes, 9.1. What about others? 9.2. 9. Check your distance. 9.5. It is very long. 9.5. It is very long. If you made the mistake while taking the readings, then it will be wrong. So 9.1. So I will take 9.1. Whatever answer you will get, it should be 9.1 or maximum 9.2. So 9.1 into scale, 1 centimeter is equal to 10 Newton per mm square. How much centimeter is there? 9.1 into 10 is equal to 91 Newton per mm square. Then DE distance. What is the DE distance? Vertical distance to calculate the sigma T. Yes, 3. DE distance 3.1. Again 3. So maximum I hope 3 centimeter is the maximum times you will get. So I will take DE distance 3 into 10 is equal to 30 Newton per mm square. 3. I will take 3 centimeters, so 3 into 10, 30 Newton per mm square. So do the calculation and write down the final answers. 3 into 10 is equal to 30 Newton per mm square. Then for the sigma R calculation, OD distance, What is the OD distance? Total inclined line, dotted line. 9.5, 9.3, 9.6. So maximum 9.5, 9.5. So I will take the 9.5 only. So 9.5 into 10 is equal to 95 Newton per mm square. So whatever the answer you will get through your figure, you write down that answer only. So 95 Newton per mm square, this is the resultant stress. Then measure the angle DOE. It represents the angle of obliquity as a phi. Yes, what is the angle of obliquity? The 19 degree. Yes, 18. Any another answer? 18, 19. So I will write both 18 degree or 19 degree. 19. Yes. So 18 or 19. No problem. Both the answers will be accepted. Okay, so 18 degree or 19 degree. So this is the procedure for the case number 3. Only small difference is there. Instead of taking the center point C directly from this particular point A and from this particular point D, first of all represent the shear stress in vertical direction. Maybe one shear stress in positive region, another stress is in negative region. Then join that particular points, you will get the inclined line, and due to that inclined line, automatically you will get the C point. But in the case number 2, you have to take the center point as a point C. But in the case number 3, due to that particular inclined line, you will get the center point automatically. Then take the inclined radius only, either CH or CG, and draw one circle. And once you have drawn the circle, again to represent the 2 theta angle, select the inclined line only. केस नंबर 2 मध्ये आपण पॉइंट ए पासून अँटी क्लॉकवाइज डायरेक्शन मध्ये 2 थीटा अँगल काय करत होतो, रिप्रेझेंट करत होतो. पण केस नंबर 3 मध्ये आपण काय करतोय, इन्क्लाइन्ड लाईन किंवा जी पॉइंट पासून आपण अँटी क्लॉकवाइज डायरेक्शन मध्ये 2 थीटा काय करतोय, रिप्रेझेंट करतोय. सो ड्यू टू दिस पर्टिक्युलर 2 थीटा representation, you will get the new point on the circle which is called as a point D. Once your point D is finalized, from that point D, again same, draw the vertical line, you will get the new point E on the horizontal axis. Then join OD distance, and whatever the unknown parameters are there, represent all that unknown parameters on the Mohr circle diagram. Then measure the dimensions, multiply by the scale, you will get the correct answers. Now if you have to verify these answers analytically, so we are having the formula. Let us see. Sigma n is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta. You can see in the analytical formula also 2 theta term is there. Therefore, in the graphical also I have taken the 2 theta. We have to verify the answers. Plus tau into sine 2 theta. So please check whether this formula is correct or not. I will also check and put all the values in this particular equation. For the case number 3, what is the sigma n formula? Yes, cos 2 theta plus tau into sine 2 theta. So put all the values, sigma x, sigma y, tau and the theta, and please tell me sigma n, whether it is near to the 91 Newton per mm square or not. Just we will verify with the single formula. Put all the values and tell me the answer. Sigma x is given, sigma y is given, shear stress tau 20 Newton per mm square, 2 theta angle 45 degree. Yes, 90. Sigma n is equal to 90 Newton per mm square. So others, please check your answer whether it is coming 90 Newton per mm square. So those who got this OE distance as a 9 centimeter. So those who got this OE distance as a 9 centimeter. So 9 into 10. 90 Newton per mm square. So clear cut, your graphical answer and the analytical answer will be matched. But no problem, sometimes you get the 9.1, 9.2. It is also accepted because we are considering all the types of errors in the graphical method. So don't worry about that, you will get the marks 100%. But whatever the answer you will get from your figure, that answer only you have to write. So please check your answers whether it is 90 Newton per mm square or not through the analytical method. Similarly, you can use the formula of sigma t, you can use the formula of sigma r, you can use the formula of phi. Same answers you will get. Yes, sigma t is 30 Newton per mm square. One student has represented sigma t is equal to 30 Newton per mm square, and our answer is also 30 Newton per mm square. That means whatever the answers we have calculated through the graphical method, I have compared that answer with the analytical formulas, and from that comparison, whatever the calculations I have done, it is 100% correct. So this is about the problem based on the case number 3. So same procedure we have to follow for all the types of problems, but only small changes there for the case number 2 and the case number 3 for the representation of C. In the case number 2, the shear stress is not given, therefore you will not get point H and G. But in case number 3, you are having the shear stress also. So by using the sign conventions of the shear stress, whether it is located in the positive region or the negative region, their value, you will get the point H and G. And then by taking the inclined radius, we have to draw the circle. The remaining procedure will be same. That is, you have to locate the 2 theta, you will get the D point, and from this D point, you will get the another. Yes, sigma R, resultant stress also 94.86. Yes, sigma R is also 94.86, means approximately it is equal to 95 per mm square. Correct. So all the answers I have verified. Then check that phi also, whether it is 18 degree or 19 degree or it is in between that. Sigma n also verified, sigma t is also verified, sigma r also verified. Then check the phi angle, tan inverse of sigma t upon sigma n. 18.43, no problem. 18.43, it is in between 18 and 19 degree. So your 18 degree is also accepted, 18.43 through analytical method it is also accepted, and 19 degree it is also accepted. Yes, 18.43. So many times if they have asked check your answers analytically, so you have to solve this particular problem by the graphical method also, and at the end you have to use these equations and we have to verify whether given calculation is correct or not. Okay, so this is about the problem based on the case number 3, and with this we have finished this particular chapter 3 based on the principal stresses and the strains. Okay,